Hey math enthusiasts, I'm here to review some problems from chapter 10 for you guys. Alright, we're going to start off with just determining what these figures are inside my picture, whether it's a segment, a point, or a line. So the first one I'm looking at is segment DB inside my circle, and it looks like it goes from the center of my circle to the edge of my circle. So that means it has to be a radius. Next one after that I'm looking at is line CE. So this one's up top. It continues on forever in both directions. It only touches my circle at one point. So in that case, I know it's a tangent. Next one, though, I'm looking at is line CB. All right, well, this cuts through my circle at two separate points at C and B, so I know it is a secant. After that, I'm looking at segment AB. So this cuts all the way across my circle, so it has to be a diameter. And the last one, segment CB. So in this case, the endpoints are on the circle, doesn't go outside the circle, so it is a chord. For this next problem, I'm looking to solve for x, and they do tell me that QP is tangent to circle R. So what that tells me is that this right here is a right angle, and they have it marked in my picture. So what I'm going to focus on is just this right triangle, where my one leg is 30, my one leg is x, and then my hypotenuse is going to be x plus 18. So if I were to use the Pythagorean theorem, I know that a squared plus b squared equals c squared. And as I said, our hypotenuse, is x plus 18. All right, so now I just need to go through square everything, plus x squared. Now remember, this is x plus 18 times x plus 18, so don't forget to FOIL that. So I'm going to end up with x squared plus 36x plus 324. Now, right away, as soon as I start to rearrange this equation, I notice that my x squareds are gone. And I'll move this 324 over, which is going to leave me with 576 equals 36x. And then as soon as I divide by 36, I'm left with 16 for x. For this next problem, I'm dealing with two tangents to my circle. They're really just tangent segments, AB and AD. They touch my circle at B and at D, and obviously they intersect at A. So if you remember this theorem earlier in the chapter, I know that these two segments, since they intersect outside my circle, and they're both tangent, then they must be congruent. So in this case, I know that 2x squared plus 4 is going to be equal to 22. Well, we're going to end up with 2x squared equals 18. Next thing I'm going to do is get rid of this 2, which just leaves me with x squared equals 9. I'm going to take the square root. Now technically I'm going to end up with x equals plus or minus 3 when I take the square root, but it looks like in this case there's only one x that I'm worried about plugging it into. And whether that 3 is positive or negative, it's still going to give me a positive length there after I square it. So both my solutions are here, positive and negative 3. For the next couple problems, I'm worried about finding arc measure in circle P. So instead of focusing just on each one individually, let's just move over to our picture and just fill in everything we can. So the first thing I notice is that all these angles are central angles, which tells me that the arcs that they open up to, like arc KL up here, is going to be the same measurement, 87, which tells me NM is going to be 68. Next thing I notice right away is that we have some vertical angles, which tells me this central angle is 68 and this arc over here is 68. All right, moving on from that, I also noticed that JM is a semicircle. This right here is a straight angle. So therefore I know that these two have to add up to 180, which makes this central angle 112. So this arc is 112. And I can use the same idea for arc KN. So all three of these angles together are going to add up to 180. That makes this central angle 25. So this short little arc here is 25. As soon as you have all of them filled in, then you can easily find the measurements of these arcs. Now, for this next problem, in circle R, they specifically state that these two segments, AC and EB, are diameters. So I'm going to focus on segment EB. So if this is a diameter, that means that this right here is a semicircle. And all three of these angles in here have to add up to 180. So I'm going to start to set up my equation then. I'm going to add all three of these up. So we're going to have 4x, 15x, and 7x. So I have 26x, and then I have positive 3 and negative 5, which gives me negative 2. And all three of them together are going to equal 180. So I'm going to end up with 26x equals 182. And after I divide by 26, I'm left with x equals 7. But what they're really asking for is the measure of arc AB down here. So what I need to do is figure out the measurement of this central angle. All right, well, let's focus on this one right here. I just said x was 7. So when I plug that in, I'm going to have 7 times 7 minus 5. So 49 minus 5. So that tells me this short little arc right here is 44. Well, remember, this whole thing right here is 180. So all I'm going to do is 180 minus that little arc that I just filled in, 44. Which tells me the measure of arc AB is going to be 136. And there's my final answer. That's what they were looking for. For this next problem, I'm looking for the length of this segment PR. So let's see what they've given me in my picture. It looks like QS is a diameter, goes through the center of my circle, and it looks like it's perpendicular to this chord right here. Now, since that's a diameter and it's perpendicular to this chord PR, that means that it bisects it, according to one of my theorems from earlier in the chapter. Splits it right in half, which means that these two segments are equal. So I can take those two expressions and set them equal. So we end up with 2x equals 8, so obviously x equals 4. And then when I plug it in, each of these separate lengths, it looks like we have 36 minus 3. So this one's going to be 33. And obviously on this side, I should get the same thing, 28 and 5. So this one's 33. What they wanted was the length of PR, so it's going to be both of them together, which gives me 66. For this next problem, there's a couple different things I need to fill in. A, B, C, and D. First one I'm going to focus on, since it's up top, is angle B right here. I know it opens up to this arc, the 156, and if you remember my theorem from earlier in the chapter, if I have a tangent and a chord that form an angle, it's going to be half the measure of the arc. So I'm going to take that 156 and I'm just going to divide it by 2, which tells me that angle B is going to be 78. I'm going to continue to go around my straight angle here. So angle D opens up to this arc. Well, this central angle right here is 108, which means this arc is 108, but the difference is this angle is an inscribed angle, which means that it's half the measure of the arc. So that's going to leave me with 54. Next one down the line is A. Well, in this case, I don't have A or C. All right. Well, the thing is, we did just get B and D. And I know that these three together are going to add up to 180. So I'm going to do 180, and I'm going to take away the two angle measures that I do have, which leaves me with 48. So now I know angle A is 48, and angle A opens up to arc C, and I'm going to use the same theorem that I used earlier between those two. So I'm going to double that angle measure, which is going to give me 96 for C. Next problem, I'm once again trying to solve for A, B, and C. First thing I notice in my circle is that this segment right here goes through the center, which means it's a diameter, which means that we have a semicircle on the top and the bottom. Well, if this right here is a semicircle, meaning it's 180 degrees, then angle A up top here has to be half that measurement. So it has to be 90. Other thing I noticed is that we have 74 over on this side. Well, these two arcs together that I highlighted in blue form a semicircle. Together they're going to make 180. So that means this side on the left has to be 106. And then we have angle B. That's an inscribed angle that opens up to that 106. So it's going to be half that measure. So angle B is going to be 53. Last one I'm after is C. Well, the one clue they give me is the 40 up here. Now this is an inscribed angle. It opens up to this arc. So I know this arc is going to be double that amount. I know it's going to be 80. And once again, we have a semicircle down on the bottom half. So that whole thing's 180, which means that C has to be 100. This next problem, I'm using my theorem from earlier, which deals with a tangent and a chord. So I know the angle that's formed by that is going to be half the measure of the arc that it opens up to. So right away I know that A is going to be half of 112, which gives me 56. And then it looks like A and B together form a straight angle. So to get B, all I'm going to do is 180 minus 56. For this next example, once again, I'm focused on finding multiple different angles in my circle. So let's start with angle 1. It's an angle outside of my circle, and the two arcs it opens to are 38 on the inside and 96 on the outside. So if you remember my theorem from the end of chapter 10, to find the measure of angle 1, I got to do half the difference of the outside arc minus the inside arc. 38. So the measure of angle 1 is going to be half of 58, which tells me that the measure of angle 1 is 29. For the next one, I'm focused on angle 2. Now, angle 2 is actually a vertical angle with this one as well. And you can see the two intersect right here, these two chords. And they open up to these two different arcs, 36 on the top right and 96 on the bottom left. So now I have to use my other theorem from the end of chapter 10. I know that the measure of angle 2 right here is going to be half the sum of these two arc measures now. So 96 plus 36. So it's going to be equal to half of 132. So now I know the measure of angle 2 is actually going to be 66. Then the last angle I'm looking for in this problem is angle 3, which appears to be an inscribed angle. which opens up to this arc, which is 36 and 38, which gives me 74 total. Now, if you remember, the inscribed angle down here is always going to be half the measure of that arc, which gives me 37 for angle 3. Now for this next example, I'm looking to solve for x. We have an angle 34 outside of my circle formed by these two secants. All right, they give us the measure of the inside arc and the outside arc. So if you remember, according to my theorem, the angle outside that 34 is going to be equal to half the difference of these two arcs. So it's the larger arc, the outside arc, 3x minus 2, minus the inner arc, x plus 6. Now I included this extra set of parentheses because you're subtracting the entire arc measure, whatever that is. So you have to be careful when you're rearranging this that you distribute this negative to both terms. But first thing I'm going to do is I'm actually going to get rid of this half right here by multiplying both sides by 2. So when I multiply this by 2, that half disappears. So I actually end up with 68, and I have 3x minus x, which gives me 2x. I have negative 2. Remember, this is going to change to minus 6, which gives me minus 8. So now that that's cleaned up, I have 76 equals 2x. So x equals 38. For this next problem, once again, I'm trying to solve for x. So they give me JL, 5x plus 6. They give me MK, 11x minus 34. And then they give me this little angle right in here. It's not a central angle, all right, but that one's the 8x plus 2. All right, well, the thing is, we do have a theorem for these angles. All right, so I know that that angle in blue, let's call it angle 1, for example. So I know that the measure of angle 1 would be equal to half the sum of these two arcs. So half the sum of these two. It doesn't matter what order I put them in because I'm just adding them up. So 11x minus 34 plus 5x plus 6. First thing I want to do is just clean up what I have in the parentheses. I'm going to keep that half up front. So I'm going to end up with 16x minus 28. Now I got to figure out, how does this relate to this 8x plus 2? Well, I know that these two angles are going to add up to 180, right? So if I do 180 minus this angle right here, then I would get angle 1. So what I'm going to do to represent angle 1 is I'm going to do 180 minus that 8x plus 2. And that's what I'm going to put down here instead of the measure of angle 1. So it's going to be, we'll just erase this one. So it's going to turn into 180 minus 8x plus 2. Remember your parentheses around here. So once again, I'm going to have to distribute that minus to both terms. Well, that's going to leave me with negative 8x. And then 180 minus 2 gives me positive 178. After that, what we can do is focus on this half right here. So since both these terms are even, I'm just going to multiply it and distribute it out. So I still have negative 8x plus 178, and then I'm going to end up with 8x minus 14. So it looks like from here we can get our x's together, get our constants together, so I'm going to end up with 16x on this side, And it looks like we have 192 over here. So it looks like x equals 12. The last thing I want to do for a problem like this, since it was so complex, is just take that x value, plug it in, and just check to make sure I'm correct. So it looks like if x equals 12, then this arc JL is going to be 66. This arc down here, MK, is going to be 98. And then supposedly this angle in here, the 8x plus 2, is supposed to be 98. Well, as I said, what I'm going to do is I'm going to focus on these two arcs. So I know that angle 1, which I called it earlier, should be equal to half the sum of those two. So 98 plus 66, which means that it should be equal to half of 164, which tells me that the measure of angle 1 is going to be 82. So I'm going to change that 1 to 82 inside my circle. And since this angle over here is 98, these two should add up to 180, which they do. For this next problem, I'm still solving for x. I'm dealing with this tangent segment right here. It touches my circle at one point, and it intersects this secant segment right here. Cuts through my circle at 2 points. So if you remember, this theorem is the tangent segment squared is equal to the external piece, 20, times the whole secant segment, which is going to be 25 plus 20. So I'm going to end up with 20 times 45, which is going to give me 900. I still have x squared over here. I take the square root of that. X is going to equal 30. Next problem is similar. I'm dealing with two secant segments. So I have RT and I have PQ. So I'm going to set it up the same way I did for the last one. So if you remember, my equation is going to be the piece times the whole thing, which is going to be 4 and 6, is equal to the piece, now the external piece is x plus 2, times the whole thing, which is going to be x plus 2 plus x. So let's clean all this up. We end up with 4 times 10, which I know is going to give me 40. And over here, I'm going to have x plus 2 times 2x plus 2. Sorry, 2x plus 2. So I'm going to have to FOIL this as I go through. So remember, we got 2x squared plus 2x plus 4x, and lastly, plus 4. So we'll clean up this right-hand side. I'm going to have 2x squared plus 6x plus 4 equals 40. Now I can tell right away we have an x squared, I have an x, I have a constant. I'm going to have to factor. So in that case, I'll move it into standard form and get it set equal to 0. So I'm going to factor out that 2 that they have in common to make it a little bit easier. So we got x squared plus 3x minus 18. And now I should be able to factor it. So that 2 is going to stay on the outside. Factors a negative 18 that are going to add to positive 3. So it looks like we can go with 6 and 3. And I'm going to make my 6 positive and my 3 negative. So my final answers for x are going to be positive 3 and negative 6. But it looks like if I go back and look at my picture, I can't have any negative values. So it looks like it's just going to be x equals 3. For this next problem, we have intersecting chords inside my circle. So if you remember, for this theorem, it's going to be the product of those two pieces is equal to the product of the other two pieces. Now remember, when you multiply these together, we have x times x, which is going to give me 6x squared equals 30. X squared equals 5. So that means x is equal to the square root of 5. Can't break it down, so we're just going to leave it like that. For this next problem, I do want the length of the diameter, but let's just focus on solving for x. So technically, I have two chords that intersect inside my circle. So I'm going to do the same thing I did for the previous problem. I'm going to multiply the two pieces together and set it equal to the product of these two pieces. So it's going to give me 2x times x minus 2. So x times x is going to give me x squared. On the right hand side, after I distribute, we end up with 2x squared minus 4x when I multiply those two together. Looks like we can get rid of this x squared, so that's just going to leave me with 1x squared. Move the 4x to the other side, and the last thing I'm going to do is just get rid of one of my x's. So it looks like x equals 4. But what they really cared about is the diameter. Well, in my picture, since these two are perpendicular and this chord is bisected, that tells me that this segment running vertical is the diameter of my circle. So if x is 4, this lower piece is obviously going to be 8, and then this top piece is just going to be 2. So my diameter is going to equal 10. For the next problem, we want the equation of a circle. So remember what your standard form is for the equation of the circle. X minus h squared plus y minus k squared equals the radius squared. So I'm going to need the center, which if you remember is your h and your k, and you're going to need the radius. Alright, the only thing they give me to start are just these two endpoints on the diameter. So the first thing I need is the midpoint between those two. The midpoint of the diameter is going to be the center of my circle. So if you remember, you're going to do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So I'm essentially just taking the average of my x's and my y's. So I'm going to end up with 2 divided by 2, and I'm going to end up with 6 divided by 2, which just gives me 1, 3 for my center. So the center is 1, 3. Next thing I need is my radius to complete my equation. Well, to find the radius in a circle, you just need the distance from the center to any point on the circle. Doesn't matter. So let's do the distance from my center to -2, -1. So I'm going to have to use the distance formula. So it's going to be x2 minus x1 squared. And then I'm going to have y2 minus y1 squared. Both of them are double negatives in there, so they're going to turn to positive. So we're going to have 3 squared plus 4 squared. You can already see where this is going because it's going to be one of my triples, which tells me that my radius is 5. Last thing I have to do is just plug everything into my equation. Remember, this is your h and this is your k. So my final equation is going to be x minus 1 squared, y minus 3 squared, and then it's equal to my radius squared, remember. So it's going to be equal to 25. For this next problem, now we have to actually graph the equation of my circle. So I'm going to need two things. I'm going to need the center, and I'm going to need my radius. Well, remember, our equation is equal to r squared. So if r squared is 9, that tells me that my radius must be 3. Next thing I want to look at is my center. So remember, it's x minus h, which is the x-coordinate of your center, which tells me that's positive 1, and y minus k. Well, it's just y by itself, which tells me k is going to be 0. Now we have what we need to graph my circle. Center is at 1, 0, and my radius is 3. So I'm just going to go 3 units to the right, 3 units down, 3 units to the left, and 3 units up to get an idea of where my circle is going to go. And then just try to do a rough sketch connecting those points to form your circle. Last problem from the review. What I want to do is figure out the center and radius from this long equation that they give me. Well, the problem is that it's not in our standard form. X minus h, y minus k squared equals r squared. So what I want to do is I want to rewrite it into that form. First thing I'm going to do is rearrange it. So let's get our x's together. X squared minus 12x. Going to leave a little space. I'm going to have y squared plus 8y. And I'm going to take that 48 and I'm just going to move it to the other side. So it's going to be equal to negative 48. So if you remember, what I have to do for this problem is I need to get it into this standard form, which means I essentially have to factor these expressions, but I'm going to need another term here. So if you remember, to get that term, what you have to do is take that b term, essentially, divide it by 2, and square it. All right, that tells you what term is going to go in here. So it looks like for this one, it's going to be positive 36. All right, it looks like for the other one, I'm going to take that positive 8 divided by 2 and square it, which is going to give me positive 16. This will write positive 16. Now I can take each of these expressions and factor them. So this is going to turn into x minus 6 squared. This one's going to turn into y plus 4 squared. And since I added 36 here and 16 here, I'm going to add each of them to the right-hand side, which leaves me with 4. Now it's in that standard form. Now you can pick out your center, which it looks like is going to be positive 6, and since this is positive, it's going to be negative 4, and my radius